Subject concrete structures, chapter design of slabs, topic previous year gate numericals on design of slabs. So students, so now I have looked around last 20 years and this is the only numerical which I have got in past 20 years. So you can see that how much the weightage this design of slabs carry in gate examination, which I was already telling you, right? Okay, but still it is going to be a big numerical. It came in gate 2001, right? It came in gate 2001. It came in, so around you can say 20 years back this question came in examination. Clear? Now the question is the effective span for a simple one-way slab, system with an overhang, right? So an overhang is also there, are indicated in the figure below. The specified ultimate design load. So ultimate design load means that the factored loads, right? Ultimate design load, factored loads on the slab are, so 6 kilonewton per meter square is the dead load and 4.5 kilonewton per meter square is the live load, right? So what is dead load, what is live load? You must be knowing that dead load is a permanent load and live load it can change, right? So considering the possibility of live load, now this is important, considering the possibility of live load not occurring simultaneously, it means that on both the span, it means that the live load can be on this span as well as can this span, but it will not be on the both the spans at a particular moment of time, right? It can either be on AB or it can either be on BC. It depends. Clear? Consider this much. Determine the maximum spacing in mm. Determine the maximum spacing in mm of 8 mm bar or 8 mm diameter bars required as the bottom reinforcement in the span AB, assuming an effective depth of 125 meters, the effective depth given to us, and M20 grade of concrete is given to us, and Fe 415 steel is given to us. Yeah. Now the question is that you have a dead load. How much is dead load? Dead load is actually 6 kilonewton per meter square. 6 kilonewton per meter square is the dead load, and this dead load is actually constant. It is permanent on the beam. Whereas this 4.5 kilonewton per meter square, it can change. It can either be on the span AB or it can either be on the span BC. Right? Now what we have to do is that we have to calculate the maximum spacing in mm. So before calculating the maximum spacing, we must calculate how much steel is required. Yeah? Because when you know how much steel is required, the total amount of steel, if you divide it with the area of single steel bar, you will get the spacing between the reinforcement. And after that, you have to check whether the IS 456 provisions are met or not. I told you that the main reinforcement in a slab is 3D or 450 mm, 3D or 400 mm, minimum of the two. Okay, I have already told you these things, right? So first of all, we have to see whether how much the total, you can say total area of steel is coming, okay? And after that, we have to see whether the provisions of IS 456 are met or not. So before calculating the total area of steel, how total area of steel is calculated? It is calculated only when you know how much is the moment, right? Whether the live load is on this span, at that time will you have the maximum moment, or if the live load is on this span, at that time you have the maximum moment. So first of all, we have to check where should the live load be to get the maximum moment. It is my common sense that if the live load is on this part, I will get the maximum moment, but still I have to check whether my assumption is correct or not. Clear? Now let me rub the whole question. Let me just write down the important things, these loads, the effective depth, the diameter, and let us solve this numerical. It is going to be a big numerical. Okay, so let me rub this. Now let us look at this. So this question will be solved in two cases. So I have actually solved this numerical. Now I will make you understand how to solve this numerical. Okay. So first of all, the first case is the live load should be on the span AB. So first of all, we have to calculate the maximum moment, right? First of all, I will assume the live load is at AB, and then I will assume the live load is at BC. Simple, right? So live load is on AB only, the first case, right? So if I apply the live load 4.5, right? This is span is 3.5, this is 1.5 meter. So RA plus RB will be equal to this 6 plus 4.5 into 3.5 because it is a UDL plus 6 into 1.5, so it will be 45.75. Taking the moments about B is equals to 0. So RA into 3.5 clockwise positive minus 6 plus 4.5 into 3.5 into 3.5 divided by 2 minus anti-clockwise, and here we have BC, so 6 into 1.5 into 1.5 divided by 2 plus, right? But this is a basic structure analysis, basic shear force bending moment diagram things, okay? So we will be getting R8 comes out to be 16.45 kilonewton, right? Now the next thing is I have to see that where we have the maximum bending moment. If you draw the bending moment diagram for this, the bending moment diagram would be like this, something like this. So this would be like the bending moment diagram, and the shear force diagram, it would be like this, and this, something like this. Clear? So that is shear force and bending. I hope you know the concept of shear force and bending moment diagram, because that is the basic of civil engineering. Clear? Okay. So we have got the reaction at A as 16.45. Now let us take any section X. Let us take any section X, right? So RA into X at the moment at this section will be RA into X minus 10.5, because this is here 6 plus 4.4, 10.5 into x by 2, right? It will be equal to 0. I will get the value of x. X is the point at which we have the maximum bending moment. This is the maxima minima concept in mathematics. If you don't know the maximum minima concept, just draw the shear force and bend shear force diagram. The point at which the shear force is 0, it will be 1.6 meter. How do you get this point? By the similarity of triangles. You can get the point. Clear? Now it will be 1.6 meters, right? Now mx means the moment at this point, it will be equal to 12.88 kilonewton meter. Now the next case is the live load is here. Now the next case is live load is here. I have not drawn the diagram. I hope you have understood it, right? The next case is live load is on the section BC. Same, everything same. RA will come out to be 7.125. X will come out to be 1.188 kilonewton, and moment at X will come out to be 2.89 kilonewton meter. So which one is maximum, 12.88 or 2.89? Obviously 12.88. So we have to design the slab for this 12.88 kilonewton meter. And if first of all we have to assume it's a balanced slab, and area of steel can be, you can say it can be determined by mu is equals to 0.87 Fy AST into lever arm, right? So moment of resistance, it was in kilonewton meter multiplied with 10 raised to power 6 Newton mm. So you are getting 8.87 into 415 steel was given to you. Area of steel you have to determine into D minus 0.48. Why 0.48? Fe 415 was given to you in question, and D was also given to you in question. So from this, and D was also given to you in question, right? So from this, you can get the value of AST as 357.45 mm square. If you divide the total area of steel, I told you, with the single bar area, you will get the spacing of the reinforcement for a per unit width, right? So this for 1 meter, that comes out to be 140 mm center to center. Now I have to check whether the answer which I have got, it is as per the IS recommendations or not. I told you it is 450, it is not 450, it is 300, right? As per the IS recommendations or not. So 3 into 125, it will be greater than 140, and 300, it will be greater than 140. So whatever the answer I have got, it is as per the IS recommendations. It is within the limits, because this is the maximum spacing. So obviously the spacing is not maximum, is not more than maximum. Clear? So I hope that you have understood the previous year numerical, and after GATE 2001, not even a single question has been asked on the slab topic. Clear? Which I have already told. But in other examinations, ESE examinations, state level PSC examinations, almost every year 1 or 2 questions are coming from this topic. So this topic is important, right? Because GATE authorities, they are very unpredictable. If they have not asked even a single question till now, in next year they can ask 1 question. Okay? So our topic should be 100% prepared if you are expecting a very good rank in GATE examination. So I hope that you have understood this numerical. Now let us move forward, and next lecture I will be telling you what I feel is that the most probable numericals can be from the design of slabs. So let's meet at the next video and further see what the type of questions can come in GATE examinations. Thank you.